Hello guys, welcome in finite elementary class with this example. Actually here we have example about 3D solid trihedral elements, 3D linear. So I have this shape is 3D solid, okay. 3D that's mean each node have x, y and z, and I have the values of each one or each direction, and the example tell me to find B matrix for the following trihedral elements. So let's start. Actually, the first because we have a 3D, that means we deal with this element with volume. So the general rule is 1/6 determine and with this value. This is the general rule of V, and each rule take the number of element. For this example, for this rule is called for the node number 1, so that it's content of x1, y1, z1. Here for the node number 2 and node number 3 and node number 4. Substitute the values that already given in this example, x and y and z, for each node, and you will get the value of v. Okay, this is 200, or actually maybe the last value is after divided, I think. Oh, sorry. Yeah, okay, no problem. Actually, you can substitute this value and divide it by 6. You will get the value of v. Okay. Then go to for the elements, because I want to find the rule of the equation that I want to check for criteria of shape function. So here in the first slide, actually, the first of all, I already written the equation that you want to find it, and through it you can get the checking of criteria of shape function. So let's start. Actually here this is the equation, or actually the general equation, and the general equation I have AI, BI, CI and DI. That's mean each of these members, or these members or item, I got it from the values actually from the nodes. So let's start with AI equal del determined, and this is the general equation. Maybe I wrote everything it for you. I can actually make it a circle for you. I is mean for the node number 1, J for node number 2, K for node number 3, and L for node number 4. You can make it easy, like here when I substitute, this one is a1, for example. A1, I already take x2, y2, z2, and here also for node number 3 and node number 4. Or you can write as like this one here. This is a I by I, K, and L. So by letters or by numbers, doesn't matter, but I think it's easy for you to use the numbers, and I just write both of them for you to show you the steps of solution. Okay, so here I use number and substitute the value of x, y, and z for each node. So now I'm working now on node number 1. So if I am working on node number 1, so I delete the node number 1 and take it in my solution only 2, 3, 4. Same as here, A for node number 2, I use 3, 4, and 1. It's actually like a circle. You see that? Cannot start with 1, 3, 4. Okay, no, it's actually not like a sequence. No, it's just like a circle. When you arrive to another station, you start from the next station, not from previous station, because it's the previous station is not is station number 1. No, cannot do that. It's just like a circle as I draw here. Okay, so let's continue. A for node number 3, 4, 1, and 2. Same with A4 number 1. So I start here from 4, A4. So take the first one is 1. Okay, this is the node for 1. Then 2, this 2, and then 3. Okay, same with B, B1, B2, B3, and B4. Same circle, you can use it, and this is the rule. I hope it's clear for you. You can see it, and this is the substitute the values of A and B in each node, and already I got the whole last values of these determinants. Same with the C and D. So after that, substitute your values in this general equation, and you will get for the node number 1, 2, and 3, 4. Just substitute the values that you already got it from the final result calculation, this one. I hope it's clear for you. I don't like to explain how can I substitute. It's actually normal steps, so I can go on. Then I should check for criteria. So the first condition, as in the previous videos, I say it's the first one is shape function is equal to 1 for considered node. So here actually I'm working on node number 1. X is 12 and Y is 30. Yes, and Z is -6. Just substitute these values on in the equation of node number 1. Okay, equation number 1 that I already find it from this step, the slide number 2. sorry, number 3. Same way with node number 2. Just take the values of node number 2 from the first slide, x, y, and z, okay, and substitute in equation in the previous slide, and you will get the value that I actually not value, actually the right condition for 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 all values of node. So the first one is 1 and the others is 0. Doesn't matter, it's okay, you can working. I know this one is not satisfied, but it's okay, it's better than to get -2 or 3 or 10 or -19. So it's okay because 0 is close to 1. Then go to second condition is the say shape condition is 0 for other nodes. Actually, sorry, I'm sorry, I didn't solve this condition. I'm very sorry, but let's you can do by your own. Just actually when take for example, just I to mention for the second condition. Actually, if you when you will take node number 1, node number 1, okay, that's mean take the values of node number 1, x, y, and z, and substitute in the node 2, node 3, node 4. Okay, then go to, and the result you should get 0. For the node number 2, substitute the value of x, y, and z of node number 2 in the equation of node number 1, node number 3, node number 4. And the value of each equation, after you substitute your values, you will get 0. Same with node number 3 and 4. Okay, so and the condition you should get 0. So now go to the third condition. Third condition says summation of shape function is 1. Just collect the all equation n1 and 2 plus n2 plus n3 plus n4, and in the equation you have x, y, and z, and just substitute the value of each node. That's mean if I have x1 in the equation of node number 1, I have x1, y1, z1, so substitute these values in the equation of node number 1 only. Same with node number 2, I use x2, y2, z2, and for the 2, for the node number 3, x3, y3, z3, and same with node number 4. Just summation and you will get the value is 1. So if you get the value is 1, that is okay or satisfied. The last condition is summation of derivation of shape function is 0. You can working on x direction and y direction. Is up to you, but here I just solve for y direction, for x direction. Make it the derivation for each equation, these equations, okay, all these equations, make it a derivation for x, or on the x direction, and summation, and you will get the value is 0. Okay. After that, actually, because this example is very easy, just ask you to how you can find the B matrix only. So this is the general of B matrix. Okay, is actually the substitute only the value of derivation on x. Okay, and on y direction you can do by your own, because I already done for the x direction. Okay, and substitute your values that you already got it from previous slide, from this one. Like this value is for the node number 1, and this is for the node number 3, so node number 2, I'm sorry, this is node number 3, and this is for node number 5. Take it with direction positive or minus, and each one has actually each part has 3 columns. So here this is for node number 1, so that I put it the height line just to see, or to make it easy when you solve. So this is for the x, and this is this column for the y, and this is for the z. Okay, and this is node number 2, node number 3, and this is node number 4. And as I said before, each node has 3 columns, because I'm working on a 3D solid. So just substitute, and this is the final solution for the B matrix. That's all. Thank you so much for the kindly watching.